introduction. Hello everyone, ladies and gentlemen. I'm Jamerson. I'm from Paraná State, on the south part of Brazil. I studied at UTFPR, University Federal Technology of Paraná. And I'm Jamerson, and with my co-author Ricardo is here, and my professor, Professor Edson, is also here. I'm a graduated student in electronic engineering there at Paraná. And we're working on this application, angular position-based tracking algorithm for geolocation in smart city applications. Our agenda consists on an introduction, the problem that we got, the idea, and our goal. After that, methodology, tests and results, conclusion, and future work. So, introduction. Our application consists on the scenario of smart city. And what is smart city? Well, smart city is cities that uses technology and communication systems to enhance and contribute to urban quality of life and drives also sustainability because it offers a better management to the municipality to do all the management of the systems. And there it's our city, Toledo City, and there is an initiative in Toledo City to transform it on a smart city. That's where we get in. So, the vehicle tracking is an application that we need to improve in our city. We have the selective collection of recyclable waste, and that's where we got in the vehicle tracking. It offers a more efficient way for the municipality to manage the service and also keep cities informed about the collection schedule. So that's our problem that we gotta discuss about it. So we already have an implemented way to do that. We already have this approach that we call the periodic approach or time-based that consists on sending coordinates every 30 seconds. And the problem is, well, there is an example of that approach, and you can see all the dots that are recorded of this algorithm, but these coordinates are useless for route reconstruction. What it means? High consumption of bandwidth and also high consumption of energy. Our idea to solve that problem, it's common sense. That's to define a line, we only need 2 dots. These 2 dots could be when the object enters the street and when it exits the street. And the yaw angle, the yaw vector, could be used to define where a curve is made. So our idea is go from here to there and only record the coordinate when the object does a turn. That was our goal. Develop an algorithm for an IoT tracker that sends coordinates on when the vehicle makes a turn. Well, our hardware utilized that consists on a LiDgo T-Beam View 1.1. It's controlled by a ESP32 and also has a lot of transceiver module and GPS integrated on it. And our IMU sensor, natural measure unit, it's an EU6050. And we also have a local storage data on a micro SD card. That's for a photo for our prototype. That's the board, that's the IMU, and our SD, the local storage data. The algorithm implemented, well, first of all, we set an angle range for comparison, we'll discuss it later, and set the initial position as our reference. At first, we try to establish lateral one connection. If it's right, get and send geolocation, record on local data, and get position for comparison. And if the angular position has changed, do it again. Okay, in a lower level, get angular position means get angular velocity. After integrated, get angular position. And if the actual angular position is greater than the reference, then reset the reference and return angular position change. Well, angular range. It measures how much the vehicle does a turn about the yaw vector. That is our variable. And we test both sets with 30 degrees and 45 degrees configuration to see which one is the most accurate. So, the experiment. Well, that is the Santa Clara 2 bus route at Toledo City. And we choose to work on our test on a bus route because the bus line has a steady route and also it's better for repeatability. So our test was carried out on that situation. We test both together, both trackers together, the periodic one and the angular position based other. In total, 6 tests were carried out, 3 tests for each angle configuration. So let's talk about some results. Angular ratio, about 30 degrees configuration. That's a clipping of the text. We will discuss it later. We also have it here, the 45 degrees configuration, and that is a clipping of the test. Side-by-side configuration. Well, you can already see that our position based with 45 degrees configuration has recorded less red dots than the 30 degrees configuration. Well, the red dots are the dots that was recorded, but they are useless for the route reconstruction. You can see that with the 30 degrees configuration, we have a way more than the 45 degrees configuration. A quantitative comparison results that the reduction of the 45 degrees configuration was more than 10%. Well, with the register, we recorded 10% less than the 30 degrees configuration. So to get on our application, we will go with the 45 degrees configuration. The periodic approach. Well, remember, this is the bus line, the bus route, and that is our result with the periodic approach. You can already see some similarities between them and see the dots and our angular position based algorithm. That is our results. In a side-by-side comparison, you can already see that is less density of dots recorded here and there. And a quantitative way, our new approach has recorded almost 35% less than the periodic time approach. So it's a reduction of energy, it's a reduction of bandwidth without less the possibility to reconstruct the route. That is our goal. Other experiment clippings that we got about sampling time, route reconstruction, stops, and straight lines. Well, sampling time. You can see here on A, it was recorded with the time-based algorithm, and C, it's the next one geolocation recorded. You can connect the 2 dots passing through B1 or passing through B2. So you cannot assure for each way the vehicle has passed through. But with the position-based algorithm, if you know when the object makes a turn, you can see that the object passed through A and B1, and after this go down. With the periodic approach, you cannot assure that. So our approach is greater accuracy and determining the route with the angular approach. And also about the route reconstruction. We have here another clipping. It's the same test, it's another clipping. And we have here our timestamp says that the point A comes first and point F comes at last. Okay, A, B, C, D, E, F. And you know that on point A, the object has turned left, and at point B, the object has turned right, and so on. Well, with the angular position-based approach, we can reconstruct the route even if one frame is lost. Let's suppose that point C was not recorded, was not sent to the gateway. So we can connect the dot B and D, assuring that the bus has passed through point C, because we know that point B turned right, at point D it turns left. So even if one frame is lost between 2 others, it's still possible to determine the route by knowing the change in direction. And of course, about stops. The time approach will record every dot and each 30 seconds. So in traffic lights or bus stops, it will happen. And I say here about traffic jams also. Like in big cities, it has a lot of traffic jams. So our approach is the best results. And about the straight lines, I already introduced you about it. So that is a straight line in your test that our approach has recorded only the 2 dots and an error here because it's a buzz stop, but the beginning and the end of the straight line. So the other approach, the time approach, has registered way more dots that are useless for our proposal. So, in conclusion, the proposed approach records fewer coordinates. It means that it reduces bandwidth and energy consumption, has more accuracy in the route reconstruction process, and is even more efficient in the case of long and time-consuming routes. So, and our future work consists in investigate to reconstruct the route itself, to reconstruct the route when more than one frame is lost, improving the curve detection algorithm through machine learning techniques. And also other applications consist on investigation the use of IMU sensor to detect road anomalies along the route, and also the driver behavior. It's also commented on the literature using the IoT tracker and IMU sensor. Well, our knowledge to Fundação Araucária in our state, and at CNPq. That's all, thank you.